Hello guys, welcome to this new session. In this new session guys, we will continue developing our end language, and which we will be focusing on scopes and temporary variables or local variables. So as you see guys here in this whiteboard, we have a simple program, and we declare a global variable, and we have two scopes, the outer scope and the inner scope. So as you see guys here, we declared a local variable called v, and then we assign different values for global variable and local variable. Then we print the local variable, and then we print the global variable. So guys, in our end language, our semantic in scopes, it's a static semantics, because when we see the beginning and the end of our scope, we know that every declaration in that scope is a local variable. And also when I want to access some local variable, I only get upper and upper until I found the local variable. So in that case we have b, so I will recognize that b is declared in a scope, then I will get upper in scopes, so b in the scope 1. So when I found that b is declared in that scope, so then it's a local variable. So if I didn't found it in the scope, so that means it will be a global variable. So guys, as you see here, we have as usual our constant array, and also we have our bytecode for that simple program. As you see, as usual, for variable declaration global variable, we load the constant to the stack, and also we define that as a global variable, and then for scopes also we load the value 2 to the stack, and also we load the value 10 to the stack, and also we set global 3, the value on the stack 10, we set it for the variable global a. So then we load 20 to the stack, and we set local variable. As you see here, we have an operation called offset local 0. I will tell you where I did found that 0 value. And then for printing local variable, I will say op get local 0, get local 0, it's the p temporary value, and then I need to print that. So I did some mistake here. I will add another print here. So excuse me guys. So what I will do is shift that a little bit, and I will add that operation that it does printing, because I get the local variable 0, then I will print it. Then for global variable, printing a global variable a, I will get the global variable 6, and 6 in the position we have a, then I will print that. So guys, that's the bytecode of that program. As you see here, we have locals, it's an array. In my problem for scoping, how I will approach that, I need to track the scope of a local variable. As you see, b, it's declared in the scope a, so I will store it in a local array that store the variable name and also its scope depth. Then when I need to print some value, I need to read or to search for that local variable in the locals. I will start from the end. If I found it, then if I found it, then I will return the index of that. If not, let's assume that b it doesn't exist in locals. That means that b is a global variable. So as you see here, when I say op get local 0, that 0 is the index or the position of that local variable in the locals array. So why is that? Because as you see, I have a value 2 and it is stored in the 2, and for me that declaration, it means the first declaration. If I found some another local variable var y equal 2, it's the second local declaration, and its position it will be in the next place. So guys, our stack state will be something like that. So I focused only on the local variable. So as you know, in our Ant language, the global variables are stored in a hash table, globals, and VM it will maintain that. In our case, for temporary variables or local variables, we will store it directly into the stack. So as you see, when I have load 2, I will load 2 to the stack, and when I have some operation that assign that local variable, as you see b equal 20, I will load 20 to the stack, and then I will assign that 20 to the 0 index of our stack, because our temporary variable b it will reserve the 0 place of our stack. So whenever I need to access or I need to override our temporary variable b, I will read it or override it from the 0 position of our stack. So if I have another local variable, it will reserve the second position of our stack, and so on. So for this case, b always it will reserve that place for itself. So guys, until now we need to track scopes in the value of scopes or the number of scopes or depth of our scopes. Then I will need to store local variables in some array, and when I need to access that or something, I need some resolver that when I ask it about some local variable, it give me the index of it in the local variables locals array. Okay guys, so for now I will jump right to the code and I will implement that concept of scopes and temporary variables. Why I did that? Because guys, when we will implement if conditions and while and for, we need that scopes. So let's jump right to the code. So guys, I previously did make a file called sample.ant. I just write that code in the example in that. So when we will finish our development of scopes, we will run our interpreter on that file and see the result. So let's go to our compiler.c, and as usual we will add blocks to our grammar. So what we will do in statement, we will add another non-terminal, and what we will do is define that block after expression statement. So what I will do is something like that. So blocks are, it start with a left paren and a bunch of declaration, and also a right brace. Okay, that's the definition of blocks. So we will go to statements function, and then I will did a matching. So else if match token left brace, what I will do is begin our scope, a function, a helpful function, begin scope, and also I will call the block function, and then I will end scope. Because remember, I do that because I have some scopes that can have an inner scope, that will have another inner scope, and so on. And scope function. So let's define these functions. So what I will do is static void begin scope. I will let it empty for now, and then I will do static void end scope, and also I will let it empty for now, and let's define the block function. And what will I do is to loop over until I found some right brace, or I found another file. So if I find another file, that means we have some error, and if I found a right brace, that means the scope is ended. So what I will call now is function called declaration. That will help us to reach any other declarations like variables, printing, and so on. And finally, if the while loop is broken, I will consume that token right brace, and then if it's not a token right brace, what I will do is I will print expect that right brace. So good. So I have used the function declaration. I will do some prototype here just to avoid errors in compilation time, because I have function declaration is declared here. Okay, now what I need to do is just to recompile our project and see what will happen. We didn't treat locals or scopes. For now, nothing will happen because everything inside the scope is like a global variable, so it's something. So let's go and do that. So let's make clean and let's make all that. So let's run our interpreter on the file sample.int. So as you see, it treats all variables as global because we didn't track scope depth and so on. So let's go and go to sample.int, and I will remove that end scope. That will usually print an error. So let's rerun our interpreter on sample.int, and as you see, we're expecting a closing brace. So that's good for now. But the only thing that our interpreter right now, it doesn't recognize that as a local variable because we didn't track anything. So what we need to do right now is to go to our compiler, So I will declare a new structure called compiler, after that structure called parser. So what I will do is defining a new structure called compiler. That compiler, it will track scope depth and all locals variables. So what I will do is I will have a tables of locals, and the maximum of that table is int count. I will declare that macro. So I will also track locals count, how many locals in that array, and also I will track the current scope of our compiler. So let's also type def struct local, and that structure, it will has a name of the variable and also its scope depth. So what we need also to do is to declare that macro in our common.header file. So let's do it. So I will go to common.h, and after that macro I will define count as the max of unsigned int 8 plus 1, because the maximum of each bit is from 0 to 255, so I will add 1 to have 256. So let's save that. So let's initialize our compiler. I will go right after current chunk, and I will do compiler, current compiler, no. So far so good. So right now I will define a function that initialize our current compiler, because I need to initialize these two values to 0 and 0, and you get the idea. So what we need to do is to define a function called init compiler. So I will go right after our parser, and I will do static void init compiler, it accepts some compiler, and what I will do is compiler locals count, I will initialize it to 0, and also compiler current scope is 0, and also the current compiler, the global variable current compiler, it will be that compiler passed as an argument. So let's use that in our main function compile. So I will go right after that. So I will declare a variable called compiler. Donc I will call the init compiler. So far so good. So our compiler is initialized, our current compiler is initialized. So now I will treat the variable declaration for in the previous session we will treat how to declare global variables and do assignment and so on. And also in that session we will go to the function that treats also the global variable, and we will do some updates to see how to implement the local variables. So let's go to it. So before jump right to variable declaration for global for local variables case, so we will go to begin scope. What we will need to do is for current compiler current scope, I will increment it by 1, and when the scope is ended I will decrement it by 1. Compiler current scope minus minus. So let's jump to var declaration function. So guys, I will do a little bit an update, because as you see here we have parse variable and I pass it parser current. So for me it's not a necessary thing, because I know who is the current token and who is the previous token. So what I will do is to update that, and I will pass only an error. In that case I will do expect variable name. So why is that is good? Because when we'll treat functions and that parse variable, it will be handful. So let's go and change that to const char error message, and here I will pass the error message. And for token here I will only passes the parser previous. And so guys, to treat variable declaration for local variables, I will go to this function, and for this function I will parse the variable. So what I need to do in that case, I will go to parse variable, and I will call another function called declare variable. I will declare it. So if our current compiler current scope is greater than 0, which means we are in a scope, so I will just return 0. I will not make an identifier constant on that local variable, because I don't want to store the name of variable in constant, because it's just local. If our current compiler current scope is less than or equal 0, which means we are in a global scope, so I will go and make that an identifier. So here I will go and implement that declare variable. So in declare variable, what we need to do is, so for function static void declare variable, I will declare that variable, which means I need to add it to some array of locals with its scope depth. So first of all, I need to check if our compiler is on a local scope. If it is not on a local scope, I will just return and end that function. So I will declare a variable called name. It will take the previous token. It's the name of our variable. So I will loop over all entries in the local arrays. So I will start from the end. If I found that, so I will shadow everything before that. So what I need to do is to decrement that counter I will start from the end of the array. So also I need to store that value of that locals, because I will use it. So then I will check if the local, its scope depth is different than -1, and local scope depth is less than, if the scope depth is less than current compiler current scope, which means we didn't found something like it, so I will just break that, because if I go over that array and I found a variable that have a different scope from the current variable that I will need to search, that means I need to break and add that variable to the locals. So I will go here and add that. So else if identifier equals name, that's that variable that I'm searching for, and also the one that I am on it on the array. So I need to erase an error that says error variable has already been declared in this scope. If I found some variable that have the same scope depth and the same name, so that means the user has redeclared that variable. For example, in the same scope, if it does something like that, one, and also it adds some other the same declaration for the same name, so that is unacceptable in our language, in our semantic language. I don't allow the redeclaration of the same variable at the same scope. So in that case I will end that function and I will return. So let's implement that add local function. It accepts a token name, and what I need to do is I will check how many locals I have in that array. If it's the maximum, so I reach the maximum, so what I will do is to raise an error that says too many local variables, and I will return. So next what I will do is to add that name, that variable in the local array. So locals, I will get the entry at the position locals count, and then I will increment that after. So what I will do is local name, I will put the name of the variable and also its scope depth. For now it will be -1. Why I did that -1? Because in our declaration of variable we have two separate things. We need to declare the variable and then we define the variable. Why I did that? Because I will not allow a user to do something like this. Let's say that is our code and we have some global variable, let's say it's x equal 1, and then the user, what it does, it's do something like x, it will have the value x. So our interpreter, it doesn't know what we will do, so I need to declare the variable and I will assign it -1. So when I will declare the variable and I will assign that, if I found that the scope is -1, and the scope def is minus, so I will erase some error that says I can't read that variable. So that's why I did -1 to scope. It will be helpful right after that. You will see the usefulness of that. So let's go and so for now what we did, we parsed the variable, we parsed the variable, and then we need to define that local variable. So what I need to do is to go to define variable, and the only thing I need to do in that is if current compiler current scope is greater than 0, so that variable is local. So remember, local variables are implicitly defined. So for definition of a local variable, we don't need to do something like define global or define local. The only thing is used in local variable is set local and get local. That's it. So in that case, so I will mark that variable as initialized, and I will add some context to it by just flipping that -1 of the scope to its current scope. So what I will do now is declare that. So I do static void mark initialized, and what I will do is something like that. If current compiler current scope is less equal 0, average. So otherwise I will go to locals array, and in the position current compiler locals count -1 scope depth. I will make it the current compiler current scope, and that's it. So in the declaration we did -1 to the variable. So when we are in the phase of defining that variable, I will add its current scope. So right now is good. So let's recompile that and see if we have any error. Okay, so what we have, so let's go to our file. Let's see, in my one current compiler. Okay, and for the other error is that so we need to take its address. So far so good. So what's next? Okay, I didn't define that function. it will compare these two tokens if they are equal or not. So let's go to our compiler and define that. So I will define it after make identifier constant here. So what I will do is static, which will return a boolean value identifier equals, so token first identifier and second identifier. So if identifier, the first identifier, its length is different than identifier 2 in its length, so I will return false. Otherwise I will return mem compare. I will compare that identifier 1 and identifier 2 and its length if that's equal to 0. So that's it. So let's write that and see. Let's clear that. Make all. So I need to add that library. Include string.h. Okay. So everything is good right now. So let's implement how to get and set these values and how to resolve a local variable. So let's go to the function variable. So what we need to do is to implement a function that resolve a local variable based on a token. So what I will do is static int resolve local. So I will pass the name of that local variable. So if current compiler in a global scope, what I will do is return in -1. So I will go over every element in the locals array and I will start from the end of that array, and what I will do, I will get that element, the first the ith element. So if I will use the identifier equals function, if the token in the that position, if that token in the ith position is equal to the token passed as a argument, then that means I found my local variable location. So what I will do is, first of all, I will see if the depth is equal to -1, because if I will resolve a function that is depth is -1, which means that user did did something like that. So like var x, it has an x. So what I say, guys, that if user did something like that, var x equal x, in variable declaration, what I will do is to declare that variable, and I will add it to the locals variable with scope -1. So when I will go to expression and treat the expression after equal, I need to resolve that. So if I will resolve that, I will find it that it exists on the locals variables. So if it does exist on the locals and its depth is -1, then that means is the user it did that case. So and that case is not allowed in our language. So let's read that, and what I will do is raise in an error. Can't read local variable. So after that I will return that position. If I found that the token, the current token is equal, when I'm resolving, is equal to something exists in our locals, then I will return its index position. So anything else I will return -1. So let's go to our variable function, and I will did something upset and upget, and I will, first of all, what I want to do is constant. I will resolve that local. I need to find its index on that token. So if that constant is equal to -1, which means that variable is not local, it's global. So what I need to do is to call the make an identifier on that, and then for the value of operation set, it will be up set global, and for operation get, it will be up get global, and otherwise it will be, for upset it will be upset local, and for up get it will be up get local. So I will remove that. So what I will do here is to directly emit bytes for upset, whatever is it is a local or global, and I will cast that constant to be a byte. So also here I will emit bytes up get, and I will also cast that constant. So that's it. The only thing we need to do is to declare these bytecodes in our chain. So let's go and do it. Guys, we will go to our chink.h, and I will add these two bytecodes, set local and up get local. So let's go to our debug.h, no, excuse me, our debug.c, and we will add that case up set local, return byte instruction, also for up get local, and what I will do is return byte instruction up get local chunk and offset. So that's it. We'll go to our vm.c to treat that. So we'll do case up set local. What I will do in set local is I will go to the position read byte on the stack, and I will pick the top value of the stack, and I will put it on that position on the stack. So I will do break, and then for case up get local, what we will do is to push the VM stack by reading that byte. Okay, and I will break. So that's it for interpreting these two bytecodes. So let's go and see what will happen on if we we execute our projects. Let's do make clean, make all, and see if we have any errors. So as you see here, we have an implicit declaration. So the only thing I will do is to go to vm compiler.c, and I will see where is that function. So identifier so that's it. So all is good. So let's go and run on that file. So I will run our interpreter on that file, and I will see what it does. So as you see, guys, I will decrease there to see the bytecode. So as you see, we have opconst 1, and we will define global 0, okay, opconst 2 and opconst 4. Also set global 3, we have set global 3, and we have that pop. We treat that in previous session, we use it in assignment, so it's fine. We didn't add that here, it's fine. So we will also load value 20 on the position 5, as you see here, and we set local 0, okay, and also we did that pop because we have an assignment, and we get local on the position 0 on the stack, and then we print that, and then what will happen is get global at the position 6, and we print that, and we return, we halt our machine. So let's see the state of our stack. We load the constant, we define that as global. So we load constant 2 because we have 2 on the local variable. We load it into the stack, and we don't have a operation code or bytecode that the like op define global or op define local. No. Local variables are declared implicitly. So in that position on the stack, the local variable exists on the 0 position. So what I will do next is load in 10, and then I will set the global to 10, and I will pop that. So the global variable, it has the value 10. Also, we have the value 2 on the stack because due to our local variable, it reserved that for himself. So also we will load 20 to assign that local variable. So what we did is offset local at the position 0. I take the value from the top of stack and put it on the local variable b at the position 0 of the stack. So as you see, we have 20. So the stack, it has 20. Then I will get local, our local variable. I will push it to the stack and then I will print it. And then we have on the stack 20, and for final instruction we need to print a global variable. I will load that global variable, that's value on the stack, it's 10, then I will print it, and finally our stack, it has 20. So the only thing we need to do is when a scope is ended, at the end of scope, I need to remove every local variable that belong to that scope. So what I need to do is to go to our compiler.c, and in the function end scope, so I need to remove every local variable. So I need to remove it from the stack, because remember, local variables, it takes a position on the stack, it owns that position on the stack. So I need, when we have a right brace, I need to remove every local variable that declared in that scope. So what I need to do is I will loop over until our current compiler locals count is greater than 0. While our locals count is greater than 0 and current compiler locals and current compiler will go to the end position. So we'll go to the end position, and what I need to do is to check if the scope def is greater than current compiler current scope. Remember, I decrement the scope. I decrement the current scope number by 1. So every variable that has a scope def greater than this current scope, that means I need to emit byte up to pop that value from the stack, and also I need to decrement the locals count by 1, and that's it. So every variable that has a scope number or a scope def greater than the current scope, and the current scope I decremented by 1, so it means that I need to decrement the locals count, which means I will remove that variable from locals, and then I will emit a pop operation to pop that value from the stack. So that's it, and I will write that, and I will make clean, and I will make all, and that's it. I will run on sample.end the same example, and as you see at the end of the stack we've for the local variable, as you see at the end of scope, we need to pop that local variable. As you see here, we have the local variable is 20, and we pop that, so that's good. And also for local variable, I load 10 and print 10, and that's and so on. So let's go to our common.h and and deactivate these ones, and let's run it on the same example and something else. So as you see, it will print B and print A. So let's go to that sample.end, and I will print that variable out of the scope, out of that scope. So usually our interpreter, it will print an error because that variable is undeclared in this scope, in the global scope. Because remember, locals variable, declaration of a local variable, it's only known inside its scope, not outside of our scope, of its scope. So let's do it. I will do and on sample.end. So as you see, why is that? Because we have an interpreter, not a compiler. So it runs everything good, and then it will print an error at line 15. Error undefined variable B. So let's do something else. So what I will do is I will declare here another variable called C that has 100, and I will print C. What I will do is print some message. C value is or C equal. So let's cast that to see the code. Okay, so as you see, we have C has the value 100. C is defined in the scope 2, and it will print 20 for B, and also it will print A for 10. So let's come back and try to print the variable C outside of its scope, and what we will get is at line 14 undefined variable C. So that's good, guys. In our session we treat scopes and its bytes code. Also we track every local variables, and also we remove from the stack at the end of the scope. So guys, in this session we did something really good, really helpful. It's scoping and local variables. It's really helpful when we develop if statement and while and for statement, and also for functions and so on. So that's good, guys. So see you in another session.